All right, what is up, guys? Mr. Rushka here. I started recording, then my Apple Pencil died, so I'm going to restart, okay? I've set a timer for 40 minutes. I'm just going to go lecture for 40 minutes, or if I finish 5.2 earlier, I'm just going to go till my phone goes off, okay? All right, so we want to find all the solutions of this equation here. Cosine of x equals 0.37, okay? So we want to give the answer in both degrees and radians, okay? So this is just like Algebra 1. We want to get x by itself, okay? Let's get x by itself. So we got to get rid of this cos here, okay? We can't just divide by cos. We have to do the inverse cosine function on both sides, okay? Whatever I do to one side of the equation, I have to do to the other. So that cos to the -1 and cos just cancel. I get x equals the inverse cosine of 0.37. So I think we should all be able to put this in our calculator at this point, okay? So if we do inverse cosine of 0.37, that's going to give me, so my calculator's on degree mode right now. It's going to give me 68.2844 degrees, okay? So this degree measure right here is going to satisfy my equation, okay? Also, any coterminal angle will also satisfy my equation. So I can take this number here and I can add 360 degrees and it will still solve my equation, okay? I can actually add or subtract 360 as many times as I want, and that result will still satisfy my equation. That's what plus or minus 360n does, okay? That just means the n here just means I can add or subtract 360 as many times as I want, and I'll get the right answer, okay? Don't forget, the problem says to give our answer in both degrees and radians, okay? So let's go back to mode, switch my calculator to radian mode, okay? Now we're going to do inverse cosine of 0.37, all right? So since my calculator's on radian mode, this is going to give me 1.1918 radians, okay? And again, I can add or subtract 2 pi to this number as many times as I want, and it will still satisfy my equation, okay? So there you go. All right? Let's repeat number 5 with this equation, okay? So we have tan x equals 5, okay? So we just got to get x by itself, just as always, okay? So we got to get rid of this tan here. So to do that, I'm going to do inverse tangent on both sides, okay? Whatever I do to one side, I have to do to the other. So the tan -1 and tan are going to cancel because that's just what they do, all right? So I get x equals inverse tangent of 5, okay? So my calculator's on radian mode right now. So when I do inverse tangent 5 in my calculator, it's going to give me 1.3734 radians, okay? And again, I can add or subtract 2 pi to that number as many times as I want, and it will still satisfy my equation here, okay? My x, I can plug my x in and get 5 out. Okay, let's do that inverse tangent of 5. Let's do that with my calculator on degree mode. All right, inverse tangent 5. That'll give me 78.6901 degrees. And again, I can add or subtract 360 to that number as many times as I want, and it will still satisfy my equation here, okay? So there you go. So that's my answer. Those are my 2 answers, okay? All right, let's go into 5.2. Verify the following. So they want you to verify that this expression on the left simplifies to sine x, okay? So let's do this. First step, okay? Let's just copy down the right side, okay? So the way you do these is you look at your expression on the left, look at your trig identity sheet. I have it right here, right? Look at your trig identities sheet, your chapter 5 reference sheet. Okay, you want to see if any of the formulas on this sheet match what you have here in the problem, and we do, right? Sine x squared plus cosine x, sine squared of x plus cosine squared of x equals 1. So I can take this sine squared plus cosine here in the top, and I can change that to a 1 over cosecant x, okay? And then we also see at this point, we're actually pretty much done. Okay, 1 over cosecant x on our reference sheet. Okay, so we have this right here. We have cosecant theta equals 1 over sine theta. Okay, if I can solve that for sine theta, if I solve this expression for sine theta, so if I multiply by sine theta on both sides, and divide by cosecant theta, right? I'm actually going to get, so these will cancel. I'll get sine theta equals 1 over cosecant theta, okay? So this equation right here, when I say identity, it just means one of these equations. So every equation here is what we call a trigonometric or a trig identity, okay? So sine theta equals 1 over cosecant theta. So going back to this, we have 1 over cosecant x is just sine x. So sine x equals sine x, which is true. We verified, okay? Let's try this one on the right here. Tan x over secant x equals sine x, okay? So let's recall, right, the definition of secant. The definition of secant is what? Secant x equals 1 over cosine of x, okay? So I'm going to change that tan x over secant x to tan x over 1 over cosecant x. Tangent x divided by 1 over cosine x, okay? Now remember, if you divide by a fraction, that's the same as multiplying by that fraction's reciprocal. So when tan x over 1 over cosine x is just the same as tan x times cosine x, okay? All right? And then if we go back to our reference sheet, where is it? Right here. We see that tangent of theta equals sine theta over cosine theta. So if we go back here, we can change that tan x to sine x over cosine x, okay? We still have the times cosine x equals sine x, okay? And then these cosines here, times cosine divided by cosine, those cancel out. We get that sine x equals sine x, okay? So there we go. Number 3, okay? So first thing we want to do is let's distribute this cosine x. So that gives us cosine x tan x, all right, plus cosine x, all right, if we distribute to the second term, cosine x sine x cotangent x, it equals sine x plus cosine squared of x. All right. And then these, anytime you see a cosine or sine multiplied by a tangent, pretty much anytime you see something like this, a cosine or a sine or both multiplying either a tangent or a cotangent, you want to take your tangent and cotangent. This is just a rule of thumb. And you want to change them using these identities right here, okay? So tan is sine over cosine, cotangent is cosine over sine, okay? So we have cosine x times sine x over cosine x plus cosine x, sine x, and then that cotangent becomes cosine x over sine of x. And that's just from my reference sheet, okay? All right. So that this term here on the left, that there's a cosine times sine x divided by cosine x, right? That top and that bottom will cancel. I'll just have sine x. Over here, the sine and the top and bottom will cancel. This gives me cosine x times cosine x, which is just cosine squared of x. Okay? And so then I see that the two sides are equal. Okay, so that's good stuff, right? So that's number 3. Let's go down to number 4, okay? We want to verify that tangent x plus secant x equals cosine x over 1 minus sine x, okay? So let's think about how we might think through this. Okay? We have 2 terms on this side and 1 term on this side. Okay? So if the left is supposed to equal the right, we probably need to combine these 2 terms somehow. Okay? We got to think how we might add these together. Okay? Well, we can't do it in their current form, but we can do it in their fraction form, right? Tangent x and secant x can both be written as fractions, okay? If you look at your reference sheet, you'll find that tan x equals sine x over cosine x. And secant x equals 1 over cosine x, okay? All right, so that equals cosine x over, so that's what we've got to get to on the right, okay? Good stuff. Okay. So now let's add these 2 fractions together. They have the same denominators, so we can just add straight across the top. We get 1 plus sine x over cosine x equals cosine x over 1 minus sine x. Okay. All right. So that's where we are there, okay? We got to think, how am I going to get, so we're close, right? We got to get the denominators to match up, okay? So this fraction on the left here, I need to have a 1 minus sine x in the denominator of my fraction on the left, okay? So I'm going to make that happen. I'm just going to multiply this fraction on the left by 1 minus sine x over 1 minus sine x. And I can do that, right, because I'm just multiplying the top and bottom by the same thing, okay? So I'm not going to distribute the bottom yet. You guys will see why. Okay, I'm going to leave that. Sometimes it's not the best to just FOIL things out. Okay, sometimes it's good to just leave it like that. The top, if I FOIL out, I'll get 1 squared, which is just 1, outer plus sine x, inner minus sine x. So my outer and my inner products will cancel. I'll be left with 1 minus sine squared of x. We've still got to equal that fraction on the right. Okay? We've still got to get to that fraction on the right. Okay? So we got to figure out a way to get a cosine x on the top here, right? And then cancel. We want to try to cancel this cosine x on the bottom. Okay? So how can I get there to be a cosine on top here? Okay, if you're stumped, take a good hard look at your reference sheet. Okay? Looking at my reference sheet, right? I don't have 1 minus sine squared on my reference sheet. But I do have an equation that has a 1 and has a sine squared in it. So what I can do with that, okay, So I'm going to copy that down here. Okay, I just changed it doesn't matter what variable I use, okay? They apply to all variables. I'm going to subtract a sine squared x from both sides. And what that does is it gives me an expression, right? It gives me an expression for the problem I have in my numerator here. So it tells us that 1 minus sine squared x on the right equals cosine squared of x. So I can replace that 1 minus sine squared of x with a cosine squared of x. Okay. And then cosine squared, right? That's just cosine times cosine. Right? And one of these will cancel with that cosine on the bottom. I get cosine x over 1 minus sine x. That equals cosine x over 1 minus sine x. Okay, so I'm verified. I'm good. I need some more water. So I've got a bit of a cold while I'm filming this. All right, let's do number 5 here, okay? So the same thing's going on, or a very similar thing at least. We have tan squared x over secant x plus 1 equals 1 minus cosine x over cosine x, okay? All right. What should I do? What should I do? Okay. We got to think about this. All right, let's take a good look at our reference sheet. So I'm going to get rid of some of this work here. Okay, so we've got these 3 equations here. What should we do? What should we do? We've got to start from the left and get what we have on the right somehow, okay? So what are our options? So we have tan squared x and a secant x plus 1. Let's see what we have to work with. So there's a formula, there's an equation right here that involves tan squared x, so maybe we could use that to change something. I don't know. You tell me. Okay? We always want to keep these in mind, right? We want to keep the equations that let us change our secants and tangents to fractions. We want to keep those in mind, okay? All right, so these are things that are familiar. Okay, these 4 that I highlighted in yellow, right? These are at least equations that involve the stuff we have in our problem. Okay? Sometimes you just got to go trial and error with this stuff, okay? So let's try this, okay? If we take this equation, we subtract the 1 over, right? We get tan squared equals secant squared minus 1. Let's take that tan squared in the top of my equation. Let's change it to a secant squared of x minus 1. All right, I just copied down the right. All right, so I have secant squared x minus 1. Okay, secant squared, okay, secant squared of x is a number, namely secant. It's a number squared, so it's a perfect square. 1 is a perfect square. Okay, 1 is a perfect square. So this is a difference of squares in top here. Let's factor that. So that's going to factor to secant x plus 1 times secant x minus 1. right? We have the same denominator there, okay? And notice that these two are going to cancel. Secant x plus 1 on top, secant x plus 1 on bottom cancel. So we have secant x minus 1 equals 1 minus cosine of x. Okay? All right, oh, sorry. All over cosine x, sorry. Okay. So what we're missing on the left, right, this should be a cosine, right? And we're missing a cosine x in the denominator. So what I'm going to do, I'm going to write this as secant x minus 1 all over 1. Is I'm going to force myself to have a cosine in the bottom by multiplying the top and bottom here by cosine over cosine. Okay? So this is going to give me cosine. So this cosine, right, we have to distribute it. Cosine x, secant x minus cosine x all over cosine x, right? That still has to equal the right side somehow. All right. So then let's think. We're really close, right? We have everything. Everything's the same except we have instead of a 1 here, we have a cosine x minus secant x. Well, what is secant? Secant is 1 over cosine, okay? So cosine of x times secant of x equals cosine of x times 1 over cosine of x. Those cancel. That just gives us 1. So this product here is just 1. Good, okay? So luckily, the way I tried worked the first time around, okay? All right, if you're on a quiz or test and you try something, okay, be careful of erasing it. I'll give you guys scratch paper. Don't just erase everything. I'm going to try to give you partial credit, okay? But what I did was, right, I started from my original problem, okay, and I'll be honest, I wasn't 100% sure how to do this when I first looked at it. What I did was, I'm starting with the left, I went over to my formula sheet, my reference sheet, and I looked for equations that included the stuff I was looking at on the left side of my problem. Okay, so that's what you want to start with when you're stumped, okay? Then at a certain point, you just got to go for it. Okay, you just got to pick, you had to pick one of those 4 pink equations and just had to go for it, okay? All right, let's go back to the 5.2 notes. Okay. So I'm going to move this a little bit out of the way. So we have sine t over 1 minus cosine t plus 1 plus cosine t over sine t equals 2 times 1 plus cosine t all over sine t. Okay. All right. So let's think about this, okay? So we've got to get the stuff on the left to equal the stuff on the right. How do we do that? Okay. Well, we have 2 terms on the left. What we need is we need to be left with only 1 term, okay? So we probably need to combine these fractions, okay? How do I combine fractions? Okay. So what I'm going to do, yes. What I'm going to do, do I want to do that? Okay, I just saw the best way to do it. I'm trying to think of the best way to explain this. Okay. There we go. I want to combine these 2 fractions, but I want them to have the same denominator, okay? So your gut reaction might be, okay, let's just multiply this guy by sine t over sine t. Let's multiply this guy by 1 minus cosine over 1 minus cosine, right? That might be your gut reaction, but that's not the correct reaction to have, okay? Here's how you want to do this, okay? So 1 minus cosine t has to somehow become a sine t, and we can make that happen, right? So let's look at our reference sheet. Okay, these 3, I'll be honest, guys, these 3 are going to be the ones that you use the most often. Especially this top one, sine squared plus cosine squared equals 1. So if we start from sine squared plus cosine squared equals 1, right? Right? And we subtract over the cosine squared of x, that'll give us sine squared of x. Okay, 1 minus cosine squared of x is going to equal sine squared of x. So that's not sine, but that's close to sine, right? This is not sine, but it's close, okay? So what I can do is, all right, and so I have a 1 minus cosine of t, which is really close to 1 minus cosine squared of x, which is equal to sine squared, which is really close to sine. Okay, so let's try to turn this into a 1 minus cosine squared of x somehow. Okay, the way we do that is we multiply it by the conjugate. So we're going to multiply the top and bottom of this fraction by 1 plus cosine of t. Okay. All right. So I'm going to erase this now. Or I'll move it. I'll just move it down. Okay. So on the top, I'm going to have sine t times 1 plus cosine of t. All right. Now beware. Okay. Beware. So this blue factor here is exactly what I want right here. So I'm actually not going to distribute this sign out. Okay, I'm not going to distribute that. Okay, because I've already got, instead of distributing it, I want to try to find a way to cancel out my sign. Okay, on the bottom when we FOIL, this is a difference of squares technically right here. When we FOIL that out, we'll get a 1 minus cosine squared of t. All right, and then we have plus equals 2 times 1 plus cosine t. Just copy down the right there, okay? Now let's use this identity down here, okay? So that's going to change my 1 minus cosine squared of t to just a sine squared of t. All right, and then right here, right, sine squared in the bottom, that's just sine times sine, right? So these are going to cancel. I get 1 plus cosine t all over sine t plus 1 plus cosine t all over sine t equals 2 times 1 plus cosine t all over sine t. Okay, so these two fractions here now have the same denominator. I can add straight across the top, okay, so I'm just going to combine my like terms. 1 and 1 are like terms. Cosine t and cosine t are like terms. So that's going to be 2 plus 2 cosine t all over sine t equals my right side. And if I factor out this 2 right here, right, that just gives me 2 times 1 plus cosine t all over sine t equals my right side there. Okay, so there you have it. Boom, we're matched up. All right, so if you're intimidated, just know that that's pretty common. I was very intimidated the first time I saw this, okay? You just want to look at your problem and see, okay, what part of my left side is similar to my right side, okay? And what that I see on my left side do I also see on my reference sheet, okay? Keep in mind you're going to be using this part the most, okay? All right, you guys take care.